stream just like died on me, bro. I hate when this happens. Like, it just cuts everything off. It's like a power surge. It's like my power sockets in my wall can't I think that's what it is. It's like the energy. I sound like an idiot right now. I don't know what I'm saying. Like it's too much power flowing through the circuit, and so it like hot wires it or whatever, and then it flicks off my computer basically. But not my actual computer. I think it's just, I don't know what it's doing. It's like frying something, and it like, because my computer actually stays on, but it like flips off and on. It's really annoying actually, because I don't know how to. I basically have to restart the stream basically, right? Like all I do is record lives because I don't feel like editing videos, so I don't know. Guess we'll keep going. Alright, if number of songs is not equal to this, I think this is what I'm supposed to do right here. Where am I messing up though? Wait, what did it just say? Looks like there's an indentation error in your if statement that should be properly indented. Here's the correct code. Edit generation was not successful. Why not, bruh? I should be. Oh, clearly. I feel silly. Okay, I think this is what I want. None. Hold on. I think I did that wrong. Wait, what? If middle name, full name. Oh, so if middle name is true, full name, else full name. so hold up then. If number of songs. You can give me all of it. Else. Give me a little bit of it. Right. Else. None. I don't know. Whatever. You ought to find it useful to pass a list to a function, whether it's a list of names, numbers, or more complex objects, such as dictionaries. When you pass a list to a function, the function gets direct access to the contents of the list. Let's use functions to make working with lists more efficient. Say we have a list of users and want to print a greeting to each. The following example sends a list of names to a function called greetUsers, which greets each person in the list individually. Alright, let's do it. I get this. What the heck? What the heck? Why is it doing that? So, for name and names, message equals hello, name, but it's gonna loop through however many names they pass through it, so we can pass like a dictionary to it. Yeah. Okay. For loop used to pass multiple names into a function. Right. I get it. Excuse me. Instead of like putting like 50 variables for it to call, you just put the for loop in here and you write it as a dictionary. Margaret? I thought they said like like Morgot. Like some Elden Ring. Morgot. Man, I'm a little bit loopy, man, because I had this like cough medicine today. My boss was looking at me like, "Are you okay?" I was like, "No, ma'am. I'm off the syrup." Not really. It was just Dayquil, but still. Usernames. Okay. Greet users. Okay, what we got going here? We define greet users, so it expects a list of names, right? Which it stores in the parameter names. Okay, the function loops the list, receives the print to each user. And we define a list of users and then pass the list usernames to greet users in our call function. Our function call, okay. We wanted our users personalized greeting, and you call the function anytime you want to greet a specific set of users, right? You're modifying the list in a function. When you pass a list to a function, the function can modify the list. Okay. Any changes made to the list inside. The function's body. Wait, is this on my stream already, dude? What am I doing? When you make a list in a function, the function can modify the list. Any changes made to the list inside the function's body are permanent, allowing you to work efficiently, even when you're dealing with large amounts of data. 3D printed models and designs that users submit. Designs need to be printed or stored in a list. After being printed, they're moved to a separate list in the phone. Dodecahedron. Setting it to an empty list. Completed models is an empty list. Okay, I got you. To none are left. Okay. While unprinted designs. Current design. Unprinted designs? Oh. I'm gonna pop them out. Current designs, which is the new designs, equals unprinted pop. It's gonna take the last item off the list and pop it out. Right? Oh, it's gonna do it until all of them are popped out. Okay. This is interesting. I see what they're doing. So all of these that are popped from the unprinted designs are going to be set to the variable current design and appended to complete models. And at the end of that, complete models will be the new list. Okay, I see what they're doing. Display all oh, hold up though. So wow. Oops. Didn't finish. Interesting. Okay. This program starts with a list. Of designs that need to be printed out in the empty list. Yeah, I got it. Completed models, and each design will be moved after it has been printed. As long as designs remain in unprinted designs. Okay, let's just follow this real quick. So we start with a dictionary with a list. We call it unprinted. Then we have another list that's empty. And while unprinted is valid, current design equals the popped from unprinted. Printing model plus current design. So it'll show what it's printing and also add to a new list. And it'll keep doing that until it pops everything. Oh, pop takes the first item, right? Then the following models have been printed. For completed model and completed models. Yeah, this makes sense. This makes sense. I get it. We can reorganize this code by writing two functions, each of which does one specific job. Most of the code won't change, you're just making it more efficient. Print models, while unprinted designs, current design. Alright, what's the difference here? Show completed. I don't understand. What did they even change? Oh, print models, unprinted designs. Complete models show completed models. Oh, I see. I see what they did. Okay. Yeah. All right, let's move a little bit. Past this now, preventing a function from with a list of unprinted designs and write a function to move them to a list of completed models. Okay. Function, list name. Oh, the slice. I remember this. Make a copy of the list. Okay. Alright, I'm gonna go ahead and save. Python work. Call it that. And then let's change up the flow a little bit here. Where is... Okay, hold on. First off, let's add this. How do I do this? There we go. Let's add that. Okay. Now let's change.
The first lecture in MIT's course,
Let's be honest though. Are we gonna do this right now?
1802 equations where lines meet. So in a minute you'll see lines meeting. The second picture, I put a star beside that because that's such an important one. And maybe new to you is the picture a column at a time. And those are the rows.
You know what? Why not? Why not? I guess the question is, is my Apple Pencil charged? Oh my gosh, it is charged. I haven't used this thing in forever. It's actually charged. I just gotta remember how I gotta do this. How do I do this? figure out how to do this. How do I do this? Start your free trial. Finish. I don't know how to do this. Mirroring. How do I... Is it on here, bro? Oh man, I'm gonna have to figure this out like after, like off stream. Cause there's no way I'm gonna figure it out right now, so forget it.
Hi, this is the first lecture in MIT's course 1806, Linear Algebra, and I'm Gilbert Strang. The text for the course is this book, Introduction to Linear Algebra, and the course webpage, which has got a lot of exercises from the past, MATLAB codes, the syllabus for the course is web.mit.edu/18.06. And this is the first lecture, lecture 1. So, and later we'll say which will give the web address for viewing these videotapes. Okay, so what's in the first lecture? This is my plan. The fundamental problem of linear algebra, which is to solve a system of linear equations. So let's start with the case when we have some number of equations, say n equations and n unknowns. So an equal number of equations and unknowns. That's the normal, nice case. And what I want to do is, with examples, of course, to describe first what I call the row picture. That's the picture of one equation at a time. It's the picture you've seen before in 2x2 equations where lines meet. So in a minute, you'll see lines meeting. The second picture, I put a star beside that because that's such an important one. And maybe new to you is the picture a column at a time. And those are the rows and columns of a matrix. So the algebra way to look at the problem is the matrix form in using a matrix that I'll call A. Okay, so can I do an example? The whole semester will be examples and then see what's going on with the example. So take an example. 2 equations, 2 unknowns.
Oh my gosh.
So
guys.
let me take 2x minus...
I'm literally logging into my notes app because I haven't done notes in so long on my iPad that it's like your password changed 3 months ago. It says my password changed 3 months ago. That's actually funny. Well, I don't know what my password is now if it changed 3 months ago. Is it this? Hold up. If not, bro, we're just gonna watch it, bro. They're not gonna stop me from watching this lecture, bro. We're just gonna watch it. Cause honestly. Oh, I got it. Oh, 2-step verification. This is crazy. Google wants to make sure it's you. What do I do? Go to my iPhone and get on the YouTube app. Okay. This is crazy. Okay, I'm good. All right.
Y equals 0, let's say, and minus x plus, say, 2y equals 3. Okay. I can even say right away, what's the matrix what's the coefficient matrix the matrix that involves these numbers. A matrix is just a rectangular array of numbers. Here it's 2 rows and 2 columns. So 2 and minus 1 in the first row, minus 1 and 2 in the second row. That's the matrix. And the unknown, well, we've got 2 unknowns. So we've got a vector, x with 2 components, x and y. And we've got 2 right-hand sides that go into a vector 0, 3. I couldn't resist writing the matrix form even before the pictures. So I always will think of this as the matrix A, the matrix of coefficients. Then there's a vector of unknowns. Here we've only got 2 unknowns. Later we'll have any number of unknowns. And that vector of unknowns, well, I'll make that X extra bold. And the right-hand side is also a vector that I'll always call B. So linear equations are AX equal B, and the idea now is to solve this particular example and then step back to see the bigger picture. Okay, what's the picture for this example? The row picture. Okay, so here comes the row picture. So that means I take 1 row at a time, and I'm drawing here the xy plane, and I'm going to plot all the points that satisfy that first equation. So I'm looking at all the points that satisfy 2x minus y equals 0. It's often good to start with which point on the horizontal line. On this horizontal line, y is 0. The x-axis has y is 0, and that, in this case, actually, then x is 0. So the point, the origin, the point with coordinates 0, 0, is on the line. It solves that equation. Okay, tell me, well, I guess I have to tell you, another point that solves this same equation. Let me suppose x is 1, so I'll take x to be 1. Then y should be 2, right? So there's the point 1, 2 that also solves this equation. And I could put in more points. But let me put in all the points at once, because they all lie on a straight line. This is a linear equation, and that word linear got the letters for line in it. That's the equation. This is the line of solutions to 2x minus y equals 0, my first row, first equation. So typically maybe x equal a half, y equal 1 will work. And sure enough, it does. Okay, that's the first one. Now the second one is not going to go through the origin. It's always important. Do we go through the origin or not? In this case, yes, because there's a 0 over there. In this case, we don't go through the origin because if x and y are 0, we don't get 3. So let me again say, suppose y is 0. What x do we actually get? If y is 0, then I get x is minus 3. So if y is 0, I go along minus 3. So there's 1 point on this second line. Now let me say, well, suppose x is minus 1. Just to take another x. If x is minus 1, then this is a 1. And I think y should be a 1. Because if x is minus 1, then I think y should be a 1, and we'll get that point. Is that right? If x is minus 1, that's a 1. If y is a 1, that's a 2, and the 1 and the 2 make 3, and that point's on the equation. Okay, now I should just draw the line, right? Connecting those 2 points, that will give me the whole line. And if I've done this reasonably well, I think it's going to happen to go through, well, not happen, it was arranged to go through that point. So I think that the second line is this one, and this is the all-important point that lies on both lines. So we just checked that that point, which is the point x equal 1 and y was 2, right? That's the point there. And that, I believe, solves both equations. Let's just check this. If x is 1, I have a minus 1 plus 4 equals 3. Okay. Apologies for drawing this picture that you've seen before. But seeing the row picture, first of all, for n equal 2, 2 equations and 2 unknowns, it's the right place to start. Okay, so we've got the solution, the point that lies on both lines. Now can I come to the column picture? Pay attention. This is the key point. So the column picture. I'm now going to look at the columns of the matrix. I'm going to look at this part and this part. I'm going to say that the x part is really, is really x times, you see I'm putting the two, I'm kind of getting the two equations at once.
All right. It's enough. I feel like crap. I'm gonna get some early sleep tonight. But what we do? We did a little bit of this, a little bit of Python, and just a tiny bit of linear algebra. We just perused linear algebra. I wouldn't even really call it. We just kind of looked at it for a second. I wouldn't really even call it much of anything. We watched 9 minutes of this video. And it's better than nothing, baby steps. So, I am off.